Good morning. This is Sarah Cook. I'm the Senior Marketing Communications Manager for Caringo. Thank you for joining us today. This webinar is geared for those who want a deeper understanding of how metadata is used in object storage. Before we begin, let's review a few housekeeping items. If you have any questions during the webinar, please type them into the question field. Brian will try to answer all of your questions today. And just a heads up, he really likes the tough ones, so don't hold back. If we don't get to your question, we're happy to chat with you after the webinar, and you can always reach us by emailing info@caringo.com. We'll have a few polling questions during the webcast, and we've also added several links to resources that you may want to check out. I'd like to kick off today's webinar by introducing our speaker, Caringo Product Manager Ryan Meek. Ryan has worked as a developer, tester, trainer, sales engineer, and now product manager in the object storage industry. Welcome, Ryan.
Thanks, Sarah, and thanks everyone for joining us this morning or this afternoon or this evening, wherever you're dialed in from. We're really happy to be here to discuss the power of metadata in object storage. This has been, I think, what we've described before as a central preoccupation of object storage and Caringo specifically, really since the beginning at Caringo somewhere in the middle of the last decade. So before we jump right into it, I wanted to just say a few things about the mechanics here. I'll start with a quick intro to object storage. This is what I usually do just to bring people up to speed in case they're joining us for the first time. This will only be a slide or two, so if you've seen it, please stay with us. Then we'll get into a brief discussion of metadata in general, what it is, what it's used for, and then a little bit of specifics about different object storage systems, including but not limited to Caringo. So without further ado, I will start right up. I also believe Sarah will be interjecting at certain points with your questions, so please add questions at any point they occur to you, and we will stop and address them. We'll also be pushing some polls in the background, so if you could answer those will help us as well. Okay, so let's get right into it.
Yes, actually our first polling question is out there. Wondering if you use metadata in your line of business. Thanks very much.
So let us know. If you have more information on that, you can also put it into questions and feedback, and we can iterate on those topics. So object storage basics. Objects are comprised of metadata and data. So this is really the central and most important part of the relationship. That's the relationship between metadata and object storage. If something only has data, it's really not an object. So metadata plus the object is the object in object storage. This is sort of the central relationship. It's a one-to-one relationship, even though metadata can be understood as singular or plural. If there are no metadata, it's not really an object. And so this can sort of instantly distinguish object and object storage from file and file storage. So object storage basics also include things like data protection, high availability, and high performance. But these come sort of downstream through a specialized architecture. Objects themselves, the metadata and the data, are generally portable, and so that goes to data protection schemes that are generally based on replication of the full metadata and data across multiple disks or multiple machines or multiple servers, but it can also include data protection strategies like erasure coding. The key point there is that the high availability and the data protection is built into the architecture, and it's not arrived at a later time through connecting legacy systems. In the ideal case, of course, some people have represented object storage as a service put together by legacy blocks, but in the pure case, object storage is architected from the ground up. And HTTP is the most common front-end protocol, and we'll see why that's really important for a purpose-built object system, and it's especially important because the containers for objects that are ideal are highly optimized for HTTP. The most really commonly available language protocol in just about any computer language for application development. The properties of large object systems make it ideal for cloud storage, and these properties are, high availability, but mostly high scale. So high scale, high performance, and optimized for HTTP.
Now, Ryan, when you say cloud storage, are you talking about private cloud or public cloud there?
So that can be private cloud, it can be public cloud, it can be hybrid cloud. People commonly construct a private cloud because they want economies of scale. They would like to be able to use standard servers, standard hardware, and have a scale-out system that can absorb new hardware and that has 24/7 uptime. They can use it as the basis for public cloud storage, for instance, as the backing services behind a public offering at a telecom or a public offering at a universal photo application site or universal application video site. But great question. So on the front end of these object storage systems, we commonly have HTTP, and RESTful interfaces are really an industry best practice. And they're especially important for high throughput and parallel processing. You essentially have a networked bank of web servers on top of a purpose-built storage layer, and that high throughput and parallel processing is actually another result of a purpose-built architecture based on things like eventual consistency and architecting away from legacy things like relational databases that depend on location and that enforce strict consistency and things like general locking. General locking, strict consistency are generally understood as a direction away from, multi-millions of transactions per second. You just can't be waiting around for highly consistent answers in distributed systems. So, so that kind of API is very specific to object storage, but it's also very generally useful for applications. And it's generally useful because it incorporates metadata and data. So the envelope in HTTP actually includes headers and data. So if you go look at an HTTP request response, in a request you have header, 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 header data. In a response you have header, 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 header data. So it's already perfect for objects. Those headers are the first place that simple text-based metadata can be included and can also arrive. So no additional protocol and no additional system is necessary to either represent or interpret that metadata. And that metadata is actually the perfect place to include request information that should specifically be applied to persisting data. So, and they can apply to things like data protection, specifying, for instance, replication or erasure coding, or specifying policy information such as, designate this content as write once, read many, and if so, for how long. it's extremely powerful that no additional language and no additional mechanism is necessary to communicate that information, and it can be communicated and persisted in the basic payload. So moving into general metadata, I'll pause briefly for questions on the basics of the object storage before moving quickly into a larger discussion of metadata.
So, Brian, we've got a question, and this is something I think is really interesting, but isn't metadata the same in every storage system?
It's metadata as an idea, metadata as information may be the same across many objects, but the way that it's persisted or the way that it's used is definitely different system to system. So, and I think that, it very specifically to different object storage systems, the necessity for a central relational database that handles metadata, is a distinguishing factor of some systems, whereas sort of purpose-built, scale-out architectures based on eventual consistency and co-location of the metadata with the object is another approach. That approach, of course, is a Caringo approach. And it's, I think, generally a best practice. And we'll get more to that point a little bit later in the discussion of metadata. So I think right now I will go right into what it is. And we've had spirited arguments around the office on this point. Maybe we should call them discussions more than arguments, but the best definitions that we have, and I think the best definition I've seen, is data about data. So that is one of the first answers on this slide. Metadata is data about data. It's also information in general. So information about the data. The general recommendation or general best practice is it should make the object self-describing. So whatever the data are, the metadata should be describing that data. In a relational database world, many times you would have some entity, and then you would have some table with information about those entities. And so for people coming from a database background, the information in that table are perfect things to represent as metadata in an object. So metadata is definitely information. It's definitely part of every object. It's a required part of every object, or else it's really not an object. It's just data. And one of the coolest quotes that I have heard about metadata is that it's a love note to the future. And
that is so poetic.
And it came out of the Internet
Archive. I love it.
And Jason Scott, who is a great follow on Twitter. If you're looking for a great follow for people that are also strangely obsessed about metadata, I think he would certainly qualify and agree with me. But what does he mean by that? In a lot of cases, when we started, we would give the recommendation, make objects self-describing. And so if you're coming in through a REST API, you have the opportunity to do that by including information about the object that's obvious at the programmatic level, and including it in a way that it gets persisted with the object. And even if it's coming in from a more programmatic method, so for instance, a purpose-built object over NFS share, there's an opportunity there at object inception time to include quite a bit of information about what that object is. And the future part is, it's not necessarily future-proofing an object, but it's making that object more useful in the future. And we will see why it makes it more useful in the future on the next slide. Of course, the answer on this slide, if there is an answer, is all of the above. So what's the future-proofing part? Well, it's not really future-proofing, right? It's some kind of making the object more useful. But how does it do that? So, right, there's different kinds. Metadata could be described in different ways. Sometimes it's information about the container. Sometimes it's information about the actual data. So, for instance, it can make an object playable. So what does that mean? So, for instance, if you're looking at something like media type in an object and in the headers, especially in HTTP, that can make the object instantly playable or viewable in a browser. And so it's one thing to have a billion object collection, but it's another thing to have a billion object collection that you can place with a forward proxy and then have that content rendered transparently and correctly across the world. So having the correct metadata with the objects can go a long way towards making it happen. So that pretty much covers making it playable, making it displayable, things like content type, things like content disposition, things like media type. These are all sort of HTTP aware and specific metadata that certainly help in the web content space. So it'll also make objects, and actually it won't make objects findable in the future by itself, but it will facilitate downstream efforts to, for instance, index their headers through text, which we'll talk more about. And it will make them actionable insofar as you can operate programmatically on those objects, and you can construct searches and executions like, for every object that matches these criteria, please perform this action. And that's a very simple construction, but you could conceivably take a 10 or 20 line Python script and perform virus checking on a billion object collection as long as the criteria were already represented in metadata and it was the right thing to match. So like I said, not exactly future-proof, but certainly future more useful, and that's really kind of the love note to the future part. Executable on this slide is also a great example of, if a certain emulator would be necessary, for instance, to actually take an object and execute it, then you know the correct one to go get. Of course, we wouldn't recommend doing that blindly, and of course, there would be security considerations for that. But the general point here is the more objects are self-describing, the more intelligently they can be treated in the future, whether that's for search or whether that's for execution, whether it's for display and content. So I will take a look here at some incoming questions, and we can get straight into those. So for instance, here's a question. If you can't find it in the data lake, what is the value? Exactly. So object storage, billions of files, data lake, multiple tenants, multiple use cases. If you can't find something, there is a sense in which you might as well not have it. Of course, it's better to have it and not find it than not have it, but that is certainly a good point. So here's another good question. So it says, with the metadata, you're using MapReduce, correct? And this is batched, slowing the process down. How do you divide the value from the information that is costing you money and space? So the basic premise of that question is not correct. We are not necessarily using MapReduce with the metadata. In fact, so the basic approach is, and we'll get more into it in subsequent slides, but the basic approach is pre-indexing the text of the metadata for search. And so MapReduce is not necessary either as a processing framework or as, the algorithm to back that up. And so there is no necessary, batched cost for those questions. There is a cost of indexing the text when objects are added to the collection, but that cost is paid as objects arrive and in line and is built into the architecture of the system. So here's another good question. Is there such a thing as too much metadata? Is it good? So is there such a thing as too much metadata? In other words, even though it makes sense to make objects self-describing, is there a limit to the utility? And yeah, I think the answer is yes. So if you go back to the legacy idea of a relational database, and you think of the amount of data that it made sense to put in a table about, the object, describing the document, that, is roughly the amount that I see generally makes sense. So you would say, okay, well, 5 to 10 to 50 to 100 things are a perfectly reasonable number of headers on a HTTP transaction, and that makes total sense. But 100,000 probably isn't. And I don't think there's any hard law about that. I think there may be numbers that are actually in the protocol or that, common web servers are prepared to handle. And I think I've seen them anywhere from 3,000 to 30,000. But I think generally, as a rule of thumb, I think once you get more than 50, 150, 200, then you might be in a place where it makes more sense to create another class of objects and structure, that metadata and associate them with the primary objects. So, you may have a metadata file that's 20,000 items and 20 megabytes, but that wouldn't be appropriate to put in the headers of an HTTP transaction. And we'll talk a little bit more about that. In fact, it might even be on the next slide, so that's a great way to prep that. So I'll go ahead and move on right now. There are a few questions. Great. Thank you for those questions. We're getting some great ones. So in general, metadata in object storage, it should be portable. What do we mean by that? These are sort of best practices, but it should be portable across locations. Objects themselves move across locations for a number of reasons. Some of them are data protection. Sometimes it's because replication is the data protection scheme, and that replication moves full replicas across multiple sites. Sometimes it's because of a DR policy where all the content in a primary site is also represented at a secondary site. Sometimes it's because there are more complicated topologies of clusters. So for instance, many branch offices feeding a central roll-up headquarters office in a hub and spoke system. So, clearly just think of the complexity of a hub and spoke system being backed by relational databases at each site that need to intelligently sync and keep synced metadata from objects that move also between sites where there are different tenants that are either being replicated or not replicated, and the actual topology of hub and spoke. So you're seeing rising complexity to a great degree, whereas if metadata and data are co-located, encapsulated in the same object, and the metadata moves between sites with the object, that complexity really goes away, because the metadata that makes sense at each site is the metadata you have, not the metadata you need to keep track of through third-party processes. So it should be simple. And in the case of using headers in HTTP, it is simple, especially when it's persisted in a format that is more or less native to HTTP and more or less analogous to a MIME message. It doesn't require any additional languages. It doesn't require any additional databases. The mechanism is already included in the protocol that you're using. And it should be fast. We shouldn't be blocking. We shouldn't be waiting on an answer. The performance of the entire system shouldn't change because somebody ran stats on a table that didn't have anything in it. You know, it should be inherent in a simple and scalable purpose-built system. So once you have that, then and only then, so it could be structured as well, and it could be extensible as well. So in our case, and for the example that was actually brought up by a good question, if you have so much metadata that and that metadata may be structured, then it's really outgrown its usefulness to be either placed or shoehorned into HTTP headers. And so what we've done is we have introduced some annotations plumbing where you can include as much structured data in the content of a new object as you would like. And you can indicate, you know, version information of the structure. You can indicate the language of the structure. So, you know, we think it will be, and it is most commonly XML or JSON. And then in the actual metadata for that object, you just indicate the object for which this is an annotation, or for which this is additional metadata. And so this has not only the advantage of adding the ability to do structured metadata, adding the ability for it to be extensible, but it also ensures that the object itself doesn't need to be modified. And so that's especially important in specific use cases, for instance, for digital evidence. So, you know, sometimes you have an object, you know, you have a security camera video, and you need to store it when it happens, and it's important. You know, it's important that the object is hashed. It's important that the file doesn't change. It needs to be used as evidence downstream, but you may say index it later for speech, or you may index it for locations, and you'd like to add that metadata later. So you can include an object, you can associate it with the original object, and then you can find the entire set through searching downstream. But really, I mean, the best practice and the real requirements should be the metadata services and protection should be portable, should be simple, should be fast. Once you have the basics, it's very nice to include structured, extensible, and have systems to facilitate those.
Brian, we've had several more questions come in. I don't know what order you'd like to take these in.
So I think there are a few Hadoop-related questions in here coming in.
Yes.
Let me see here if I can. I'm just reading them over, and I'm going to see if I can address them in general. So I think, you know, just to clarify, this is not an HDFS-based system, although we do have, and we have talked about previously, the existence of an HDFS connector that we distribute through our SDK. So Hadoop systems and systems where you want to run MapReduce in Spark, for instance, they can access and they can process data in Swarm clusters, and they can access and process data in many object systems, but we do not, and many object systems do not use it directly in real time to process queries and return results. And then, so another question here, do mobile devices come into play here, and how is that handled? And yes, the answer is yes, yes. You know, everything now is more and more mobile aware if it's not mobile itself. You know, web content in general is one of the primary use cases for object storage, and web content in general is more and more mobile. Metadata that indicates things like screen sizes, display ratios, you know, coding, you know, these are all leveraged in HTTP and can be really the deciding factors in making things useful, presentable, responsive. You know, responsive design itself really depends on the right metadata going back and forth to a system. So I think I will move ahead because I am noticing the time and I want to be respectful of everyone's time here. And then we will pause again for questions at the end. So I wanted to, that was a little bit about metadata in general, but I also wanted to include some very concrete examples for what I'm talking about. Sometimes, you know, we say things generally, but I think it's very good to include things very specifically as well. So in Swarm, we have a few different options, and this kind of goes back to what was hinted at by one of the previous good questions, which was, you know, what's too much metadata? Well, in some cases, people would like the actual minimum amount of metadata to enable their use case. And so we have a few different modes where we can treat metadata. And the most minimal amount we've described here as basic metadata fields, and those are basic HTTP metadata. That is sort of what we would consider necessary for enabling downstream content, enabling downstream indexing, you know, a responsive system that included domains, buckets, tenants, where you could find things quickly and get listings and perform basic operations. And there's another mode where we include more extensive metadata, and we call that full metadata. And this actually includes another thing that I want to address here. And if you look at the slide, the last header in the full metadata field is X star meta star. And what this is for is any additional metadata that an application would like to include about the object. And so this is a pattern match where you could include, you know, X company name, meta, name, X company name, meta, you know, department, or really, you know, index tokens, anything about that content. And this goes back to what I said about matching, you know, many of the things that would be in the table that would describe that object, for instance, in a relational scenario. And then at the bottom, there would just be some, there's just an example of then on the other side of including that information, you know, what it all means. This is what it means when it becomes findable, right? It's including the right metadata will get indexed, and then it's findable. And so this is a bit of a quick review too. We've talked a lot about these points, but it's really worth it to come back towards them. With the right metadata on the objects become actionable. They also enable a dynamic organization of content, and this is a lot like, you know, when you include enough metadata on an object, you can use real sort of big bucket strategies to find things. You know, I don't even bother clearing things out of my inbox anymore because I can use search to find things. I can use search to find things because the text is indexed and because there are metadata like the to field, the from field, the subject field, and you know, that organization is dynamic. It's also dynamic in, you know, how you would experience email in a smart folder, and that actually introduces the concept of another idea that we've given legs, which is the idea of a collection, and then using that collection as really sort of a saved search into documents in the future. So it's great to enable dynamic organization of content because it's always updating, and you don't end up in sort of legacy situations like, well, I already filed all these things, but now I'd like to file them in a different way. You can file them in many ways concurrently. They can be used by different many users concurrently, and this is a sea change improvement in, you know, ROI. It's a sea change improvement on user experience from the previous methods, but you know, you have to build it in up front to see the benefits.
Well, I'm relieved I'm not the only one who does that with my email.
Absolutely. Who wants to file emails anymore? I certainly do not.
Search is awesome.
So a few examples of search operations here. Anyone familiar with the search bar on their browser? This will look very familiar, but the point is you can expect search speed responses from you know, billions of objects in an object store. And so the same expectations that you have from search and from browsers, you should be able to get from an object store that is, you know, purpose-built, that includes intelligent handling of metadata, and has a search API on the front, as Caringo does. And just another note about collections. So that idea of a saved search and what we call collections, not only is it something that you could do with the features in the system, but it's also something that we've done. So in our specific case, we've enabled users through a pretty snappy user interface to define their own collections and have the objects really sort of at their fingertips that they're interested in. And this facility has also been extended, for instance, to Swarm NFS. So you can define a collection, you can, you know, define a search, and then you could say mount that over NFS, or, you know, make that available over NFS to your downstream users. So, you know, those are very specific examples of using metadata, having it indexed, and then sort of building technology on top of that and actually implementing it and making it available. So let me go back to questions here for one more time. I think we do have a few more minutes. So when do you have containers coming into play to help control metadata, or don't you see that happening? So containers in many cases, I mean, I see that as orthogonal to metadata services in a large purpose-built framework. I mean, we supplied the metadata and search services in a multi-tenant way, and I think the idea of containers in general, I see as generally orthogonal to metadata control. But if you have a follow-up question, I will pay attention to it. And yeah, I think that's a good place here. I don't know, Sarah, did you see any other questions come in that you thought would be good to address?
So, and this is going back to where you were talking about Hadoop. And I mean, my understanding is the metadata, works differently with different types of storage systems. But they asked, what apps do you use to make sure that the information is correct and clean?
Mm-hmm.
So is that a concern?
Okay, well, those are kind of two. Yeah, it is a concern, and that's a great question about Hadoop and MapReduce and metadata. So through the HDFS connector, Hadoop and MapReduce and Spark processing do have access to all of the metadata, in Swarm system in particular. And as far as correcting information goes, that's interesting. I mean, generally, objects will have the metadata that you store with them. And so correction will be really up to those same applications or those same systems that are using and can interpret that information. But I think the big point on Hadoop, MapReduce, and Spark are that, yes, metadata in the object store is available to those systems. And it's available to include additional metadata. It's also available to read and interpret metadata that are in the object stores. So I think that's a great question.
Well, this has been really informative for me, and I hope our audience has also enjoyed it. I know you don't have easy access to Ryan the way I do. I always just ping him at the office with questions, but you are free to email him questions at info@caringo.com, and we are happy to get those to him. Also, if you're on Twitter, follow Ryan at Who1971. And you can reach out to him there. We've also got a polling question for anybody who would like to have a Caringo storage expert follow up with them after the webcast. If you have more specific questions, please feel free to let us know. We'd love to find somebody who can help you.
Thanks, Sarah, and thanks everyone. It's been a pleasure.
Thank you, Ryan.